Okay, so today we're going to continue talking about exponential and log, okay? Mainly moving back and forth between exponential forms and log forms, and then simplifying and solving really, really basic log expressions and equations, okay? So from our parent functions, okay? Oh, by the way, if you have a couple colors that you want to get out, that might be helpful. Okay, so exponential form is b to the x power equals a. You don't have to, but if you would like to use different colors, it might help. Okay, let's go. All right. When we write this in log form, it's going to be log L-O-G base B. Remember that base is a subscript of A. We call that A, your argument, is equal to X. The reason I went ahead and put these in the same colors is because those are the same numbers. And there's two different expressions, those are the same numbers. Okay? All right, couple things to remember. Remember that your B value must be greater than 0, but it cannot be equal to 1. Your B value must be greater than 0, but it cannot be equal to 1. Remember that log is the inverse of an exponential. And the whole reason we really use logs is to solve exponential equations that aren't simple. Okay, and I'll show you what I mean by that. But the idea is that we're going to use logs to solve complex exponential equations. Here's what I mean by that. If I asked you to solve 2 to the x equals 8, could you solve that?
Yes.
Yeah. 2 to the x equals 8. What does x have to be?
3.
3. Okay? But if I asked you to solve 2 to the x equals 7, could you just off the top of your head give me that answer? No. You could tell me that it's approximately between what two numbers?
2 and 3.
2 and 3, and it's going to be closer to which one?
3.
3. But you can't give me the decimal approximation of that exponent. Okay? That's where logs come in. Is for more complex problems, logs help you solve those complex exponentials. Okay? And we're going to get to that kind of further down the road. First, we have to figure out how logs work. Okay? So, we're going to practice rewriting these exponentials in log form. Okay? And throughout this lesson, I'm going to show you a couple different hints. You can choose to use them or not. It's totally up to you. Okay? But you've got to be very, very comfortable going back and forth between logs and exponentials. Okay? So one thing I like to use is drop it, cross it, cross it. Okay, and here's what that means. We start off with our exponential equation. B to the x equals A. Okay? You're going to drop the B, becomes log base B, and then cross it, cross the A, and cross the X. So it's just a way of remembering those two equations I showed you on the first slide, okay? If it helps you, great. If it doesn't help you, come up with something that does, okay? All right, so let's rewrite this 3 to the 4th equals 81 in log form. So we're going to drop it. So we're going to have log base 3 and then cross it of 81 equals 4. Everyone see how we're doing that? All right, so let's try the next one. 6 to the 1st power equals 6. What's that going to be? Log, what do we say? Base 6 of what? 6 equals 1. Everyone okay with that? Okay. Go ahead and do the next two, please. Okay. Spencer, how did you rewrite C?
Log 5.
Okay, log base 5
1/25
of 1/25
equals -2.
equals -2. Okay, don't forget that those negative exponents flip our base. Okay. All right. Look at, yeah, wait.
If you were to put a parentheses around your A value, would you
Totally
write
fine.
like that? Okay.
All right. Rosie, how did you rewrite D?
Log base 3 of 5 equals x.
Great. We good on that? All right. Let's practice going the other way. Okay. Now we're going to rewrite the log equation in exponential form. Okay. You can think of the drop it, cross it again. It still works going backwards. Okay. Or you can also think of around the world. Okay. And these are just stupid little devices to try and help you memorize them. If they don't help you, that's okay. If they do help you, awesome. Okay, whatever works. All right, so if I have log base B of x equals A. Oops, sorry. Log base B of A equals x. Another way you can think of turning this into your exponential is to go start from your b around to the x, so b to the x power equals a. Okay? So, look at a. Log base 3 of 9 equals 2. So, are you going to take 3 to the second power?
Wouldn't it be the A going to the right side and then X going to the left side? It looks like,
You sure? Okay. So we raise 3 to the second power equals 9. Okay. What about b? Log base 6 of 1/6 equals -1. How could I rewrite that as an exponential equation? Awesome. Everyone okay with that?
Yep.
All right. Go ahead and do the next 3, please. Okay. Rod, how did you rewrite C?
3 to the power of 1 equals 3.
Good. Dorian, how about D?
15 to the 0 power equals 1.
Okay. And Colin, how about E?
81 to the 1/2 power equals 9.
Are all of those true statements? Yeah, those are all true equations. Remind me, what does the 1/2 power mean? Square root. Okay, radical of 2. So make sure you remember what those fractional powers mean. Make sure you remember what negative powers mean. If you have gotten rusty on your powers, say 7 cubed or 6 cubed or any of those things, I would go back and study those. Okay, you do need to be really familiar with those. Okay, let's simplify some simple log equations. Right? You want to be prepared to understand the instructions, okay? When you are asked to simplify or evaluate, you're asked to get it as basic as you can, which in most cases is going to be a simple value, okay? On a test or a quiz, I cannot tell you what simplify means. All right, so you need to make sure you're associating these instructions with the problems. All right, so for a problem like A, log base 2 of 2, what you're going to kind of do is go off to the side in a sense and kind of think about it in your head. And you want to imagine there being an equals x over here. So what you think is 2 to what power equals 2. You kind of imagine doing your around the world. So what power of x would get, when we raise 2, would give us back 2? 1. So log base 2 of 2 is 1. All right, so look at B. Log base 16 of 1. So we kind of go off to the side and we think 16 to what power gives us 1? 0. 16 to the 0 power gives us 1. So this is 0. All right, try C. So what's the little equation you think of in your head? 16 to what power equals 16? And what does that power have to be? 1. Okay, can we generalize these into a couple of rules?
If the a value is 1, then x is 0.
All right, so if your argument is 1, if you have log base b of 1, that is always going to equal 0. Because your base raised to the 0 power is always going to be what gives you 1. Okay, what's the other one? Good. If the base and the argument, so if you have log base b of b, that is always going to be equal to 1. These are really good rules to memorize. Any questions on those? All right. All right. So if you'll kind of reach back in your vault and remember, last week I told you that if there's no b value, there's no base of your log, what do we assume it is? 10. Good. If there's no b, then you assume that b equals 10. And log base 10 is what we call our common log. All right, so look at A. Again, these instructions of evaluate mean find the value. Okay? All right, so what base do we assume in part A? 10. Okay? So what's the little, equation that I think to myself? Okay, 10 to what power equals 1,000? So what is that power?
3.
Was it? 3. 10 cubed equals 1,000. Okay. On B, again, I'm going to assume a base of 10. So I'm going to think 10 to what power gives me 0.00001.
Negative.
Okay, hang on. So to make my life easier, I want to think of this as a fraction. So let's think about this. That first 0 represents the tenths place, hundredths place, thousandths, 10,000ths, 100,000ths. So how do I say this decimal? 1/100,000. Bless you. So I would write this as 1 over 100,000. Did y'all see how I did that? I just went through the places. 10th, 100th, 1000th, 10,000th, 100,000th. So I want 10 to the x equals 1 over 100,000. Okay, now I see that I have a fraction now. So it's been flipped. So what kind of number must my variable be?
Negative.
Negative. So let's think about this. I've got to get 100,000. Well, I know that 10 cubed is 1,000, right? What's 10 to the 4th? 10,000. So what would 10 to the 5th have to be? 100,000. So what does this expression evaluate to?
Negative.
Negative 5. Because it's a fraction. Everyone okay with that?
Yeah.
All right, let's try C. What's the equation I think of in my head? Good. 4 to what power equals 16? Which would be what? 2. Everyone okay with that? All right. Please try D and E. If you get stuck, ask someone next to you. All right, Lindsay, what's the equation you came up with for D?
4 to the power equals 2.
Good. 4 to what power equals 1/16? And what did you come up with?
Negative.
-2. Good. The negative flips, and then the 4 squared is 16. All right. Hannah, what equation do we come up with for E?
1/2 to what power equals 4?
Good.
And I came up with -2.
Very good. Gives us -2. Everyone okay with those?
Can we go over this E and how
So you've got 1/2 to some power gives you 4. You know you're going to have to flip it. That's why we know it's negative. So when we flip it, we have a 2, and then 2 squared is 4. Okay? All right, let's try a challenging one. Log base 5 of 25 root 5. I'm going to evaluate that. All right, so let's just take it step by step. Let's first turn this into an exponential. How would we write that? Equals 25 root 2. Or sorry, root 5. Everyone okay with that? Okay. Sorry about that. When we've got a variable in our exponent, if you'll remember, our strategy is to get the bases the same on both sides. Okay? So I'm going to use a base of 5. And I'm going to think of this as 25 times the square root of 5. So this is going to stay 5 to the x equals, how can I rewrite 25 as a power of 5? 5 squared. And how can I rewrite the square root of 5 as a power of 5? 5 to the 1/2. Everyone okay with that? Okay. When I've got on the right now, I've got the same bases. So what can I do with my exponents? I can't set them equal to each other quite yet, but I'm talking about how do I simplify the right-hand side yet? Yeah, you add them. Your bases are being multiplied, so you add them. So what is 2 plus 1/2? 2 and 1/2, or we could say 5/2. So now that I have a single base on one side and a single base on the other side, now I'm allowed to set my exponents equal to each other. So I know that x is equal to 5/2. Questions on that one? All right. Let's solve some simple logarithmic equations. All right. So I have log base 4 of 16 equals x. How can I turn this into an exponential so I can solve it? 4 to the x equals 16. So what must x be? 2. Everyone okay with that? All right, let's look at B. Log base x of 4 equals 1. X to the 1 equals 4. So what's x have to be? 4. Do you also notice one of our rules here? Yeah. Anytime your argument is 1, you know that log base b of b is how we get 1. So you know that your base and your argument have to be the same. Everyone okay with that? All right, let's look at C. Log base 3 of x minus 5 equals 2. How do I rewrite this as an exponential?
3
3
squared.
squared is equal to x minus 5.
3 squared equals x minus 5. All right, what is 3 squared?
9.
So what does x have to be? Questions on that one? All right. Will you go ahead, please, and try D, E, and F? Feel free to work together. All right, let's talk about D. Jack, what equation did you set up to solve D?
X to 1 half equals 6.
Good. And guys, what does that 1/2 power mean again?
Square root.
Square root. So basically we're asking the square root of what gives us 6? 36. I'm okay with that? All right, Austin, what equation did you set up for E?
X to the power 1/2, or no, x to the power of 3x equals 2/5.
What was your very, very first step, though? Try one more time.
2 to the power of 3x is equal to 32.
Good job. Okay. What's our next step from here?
Find the same base.
Get the same base. And Jimmy, how can we rewrite 32 with a base of 2?
2 to the 5th.
2 to the 5th. Good. So then we get to set 3x equal to 5. So x equals 5/3. Everyone okay on that one? Okay. Caroline, what's the equation you set up for F?
X to the 3rd is equal to 64.
Good. So from here, you can just think what cubed gives me 64, or you can take the cube root of both sides. Either way, what do we get for x? 4. Everyone good on these? All right, cool. Like,
If it was log x, 64 equals 2, would you have a positive, negative?
just
Just 8?
Mhm.
You can't have
because remember that your base
Oh, it
has to be greater than 0. Okay. All right. Okay, look carefully at this next one. Okay, this is 5 raised to the log base 5 of 25 power. So 5 is the base of your exponent, and log base 5 of 25 is your whole exponent. Okay? Okay, so let's think about this. We've got b to the x power equals a, right? Okay. I'm going to rewrite this using my colors. Okay. So this is 5 to the log base 5 of 25. That whole thing is my exponent. Okay. And then I'm just going to go ahead and add in my equals a to help me solve this. Okay. Basically what we're going to be doing is looking for a. Okay. Let's rewrite this as a log equation. So remember to do that. We drop it, cross it, cross it. So what does that give me?
5a equals log 5.
Log base 5 of
A
a
is equal to log base 5 25.
of log base 5 of 25. Cool. So what does that tell me must be true?
A is equal to 25.
Yeah. A has to be 25. So remember, I just kind of put in this A, right?
Yep.
To say, what does this whole thing simplify to? Well, what does this whole thing simplify to? 25. So can you see the pattern? No, because A was just an arbitrary variable that I put in there. Okay? Because I let A represent this original expression. 5 to the 5 to the power of log base 5 of 25.
Oh, so you're saying that expression.
So I'm saying this whole expression is A, and I found that A is 25. So the whole expression has to be 25. Okay? So the idea is, do you see that we've got the same base here, the same base of my exponent, and then the same base of my log?
Yep.
And then it's simplified to the argument. Do you see that?
Yep.
So that's our rule. This is another one to memorize. If you have b raised to the log base b of a power, what will that simplify to? A. So you don't have to go through this each time. As long as you recognize this rule, you can get your simplified answer. So look at 7. 7 to the log base 7 of 4x plus 3. So recognize you've got your base and your base. So what does this simplify to? Your argument, 4x plus 3.
Would you not simplify that to x?
Huh?
Would you simplify that to like -3 or 4?
No, because there's no equal sign. Can't solve anything here. Sorry, I just closed it. Questions on that? Cool. Okay. On your homework, which I'm going to pass out, you should be able to get through most, if not all of it. Okay? Remember, did we use a calculator at all in class today? No. This homework is non-calculator. Okay?
You think I can grab one?